Okay, time for the last section of chapter 2, section 2.4, compound functions. We're going to look for the series expansions of compound functions using the formulae that are quoted in formula booklet. So you've got these over here that are quoted. There's also the conditions to when for which these expansions are valid. So for example, e to the power of x, sine x and cos x, these are valid for all x's belonging to the set of real values. With ln, it's valid for all the x's between -1 and 1, not including -1, because that would clearly make that equal to 0, while the arctan is valid for -1 to 1. It's a closed interval, so we've got both -1 and 1 belonging, it being valid for. Right, so previously in the previous exercise you may have done examples like finding the expansion for ln of 1 plus 2x from scratch, or maybe sine 5x or e to the power of 4x by differentiating it 3 or 4 times before, and thus generating the terms in the expansion. Now, the idea of using the standard results that are quoted in the formula booklet, standard expansions, in this particular instance you would look for ln 1 plus x, and you just take that expansion and then you would replace that x with 2x, substitute it and in there, and then obtain. So instead of x you would have 2x, instead of x squared 2x squared over 2, and instead of x cubed you have 2x cubed over 3, which is 2x minus 4 over 2, so it's 2x squared, 3 over cubed, which is 8 over 3, remains as 8 over 3, etc, etc. Okay, so that's the idea behind the next section, trying to find, look for the shorter way of finding the expansions. Okay, so in example 10 we've been asked to use the expansions in the formula booklet to find the Maclaurin expansion, the first four non-zero terms of this expansion. There's no need to differentiate it, we're just going to look for the cos x. So cos x is 1 minus x squared over 2 factorial plus x to the power 4 factorial, etc, etc. So if we want to use 2x squared, cos 2x squared, we've got to replace the red x with 2x squared. So we're going to let red x, obviously if you are going to do it in the exam, maybe use capital X here, and then say let capital X equal to 2x squared, as long as it's obvious what we're doing. So we are going to then get cos 2x squared is going to give us 1, the first term is 1. For the second term, instead of x goes 2x squared, which is squared 2 factorial, and the next one is 2x squared, which is to the power 4 over 4 factorial. The next one, because we want the first 4 terms, the next term, this one is over 2 factorial, this one over 4 factorial, the next one is going to be 6 factorial, and you're going to get 2x squared to the power of 6. There you go. Okay, so just tidy up the coefficients, pop it into the calculator, put 2 squared over 2 factorial, you should be left with 2x squared. Here we're going to raise 2 to the power of 4, so it's 16 over 4 factorial, so that should be 2/3. Let's just check quick. I've got the calculator. I'll just do it without calculator. 2. That's going to be 16, and then 1 times 2 times 3 times 4. Oh, maybe not. So this is going to be 2/3. I think I said 3 over 2. 2/3. Maybe I did say 2/3. That's x cubed. Next one is going to be minus, so 2 to the power of 6, which is 64 over 6 factorial, so it's 1 times 2 times 3 times 4, 5 times 6, so you've got 2 and 4, that will give you 8. 8 and 6 is going to leave you 3, so we are left with 4 over 15. And here is our expansion up to the 4th term. Okay, double check you've got it right. I've just corrected my power here. 1 times 2 3 times 3 times 5. Right, that should be 45. There you go. Okay. You are asked also to okay, you're not asking that in this example. In other examples you need to state the values of x for which the expansion is valid. Here it will be all x's because cos is valid for all x's, so the same will happen for cos of 2x squared. Okay, so let's move on to example 11. So in this example you've got quite a complicated expression, 1 plus 2x, there is an ln of this expression. So if you look on the formula we've got in the formula booklet, here's the one that involves ln. Let me just quote it again. Ln of 1 plus x is equal to x minus x squared over 2 plus x cubed over 3 between minus 1 and 1. Okay, so over here we've got to split this. There's no way you could just extract 1 and write it as 1 plus something, so you need to split it using the rules of logs. We are going to rewrite our log as ln of 1 plus 2x to the power of a half minus ln of 1 minus 3x. This will give us ln of half of ln of 1 plus 2x and then minus ln of 1 minus 3x. So we're going to use our expansion in the red to first of all allow our x in the expansion being equal to 2x. So let x be equal to 2x, and then let x be equal to minus 3x. Okay, so what will we get? So here, if we got if we're working with x equals to 2x, we're going to obtain a half x, that will become 2x, minus 2x squared over 2 plus 2x cubed over 3. Let me just check how many terms we've been asked to do. The first 3 non-zero, so that will be enough. And then you've got minus, and then over here we are going to substitute minus 3x. So let's protect it with brackets. So you've got, instead of x, we'll go minus 3x minus 3x squared over 2 plus minus 3x cubed over 3. Okay. So we just need to collect the like terms. So let me just times it by a half and tidy up these coefficients. Let's do it steadily. So a half times 2x, that gives me x, minus a half times a half is 4 in the denominator and 4 in the numerator. So it's x squared. You have 8, that will cancel. So with 2, you have 4x cubed in the top and over 3 minus. Here we're going to minus 3x, so plus 3x. Here we're going to have minus, so it's plus because that minus will become positive, so 9x squared over 2. And then here you've got a minus from minus 3, that's cubed, and minus here, so that will become plus 27 over 3, so it's 9x cubed. Let's collect the like terms. You've got x at 3x, which is 4x, minus x squared plus 9 over 2. That's going to be 7 over 2 x squared, and then 4 cubed plus 27 cubed is 41 over 3 x cubed. So it's approximately equal to this answer. There you go. Let me just double check this one. 27 add 4 is 31. So what values is it valid for? So over here, if x is between minus 1 and 1, in our instance, we will have to consider 2x being between minus 1 and 1, but also minus 3x being between minus 1 and 1. So over here we are going to divide it by 2. So we've got my x is between minus a half, not including minus a half, up to a half. And over here, if I divide by minus 3, that will become a third. The signs will swap, flip, and then it's greater than minus a third. So we've got minus a third is x is a third. There you go. Now if you look at this, I mean, you can do a number line. Which one is the smaller? Where's the overlap we're looking for? So it's between minus a half and a half, and then minus a third and a third, and minus a third belongs, so it doesn't, minus a half doesn't, and half does. Where's the common ground? Obviously here is the overlap, so it's valid for x being between minus a third and a third. Okay, so this time we've got to okay, rather than starting a new video, we're going to just finish the last example of this chapter. Yeah, and then you've got exercise 1, 2D and mixed exercise. This is quite a short chapter. Plenty of new ideas there. Okay, so example 12. We're going to show that e to the power of sine x can be approximated by the following polynomial, and we are told that for n greater than 4, where we're talking about expanding it up to xn, and any values of n that's greater than 4, we can ignore these terms. So we're going to only go up to x to the power of 4. Okay, so here we've got two expansions to consider, sine x and e to the power of x. Now, if you thought it would be a good idea to substitute sine x into our expansion here, then you would have 1 plus sine x squared over 2, etc. This is going to be an infinite series, and then if you wanted after that, it would be in terms of sine x. After that, you would want to substitute these terms instead of x. It would be just a mess, because where do you stop as infinite series? So here's the trick. You're going to use the expansion for sine x. Sine x is 1 minus x cubed over 3 factorial. X cubed over 3 factorial, don't need any more. So we are going to substitute instead of the power. We're going to replace it with our expansion. Okay, now you might say, why haven't I gone further? So further ones, it would be because the power is going to be too big. So even if I try and do something with that, it's going to just potentially get bigger. We only want to stop at x cubed, so there was no need. And the next thing is to split this into two terms, e to the power of x times e to the power of minus x cubed over 6, which is 3 factorial. Okay, so now we can go ahead and have a glance at the expansion e to the power of x, which is 1 plus x squared over 2 factorial plus x cubed and x to the power of 4 as well. So we can now, instead of e to the power of x, we can write this expansion, which is 1 plus x squared over 2 factorial plus x cubed over 3 factorial. If I do, I need to go the next one as well. We'll explain in a minute why more. Multiplied by, now over here we've got exactly the same expansion, but we are going to allow the red x be equal to minus x cubed over 3 factorial. Okay, sorry, the brackets should be over here. Okay, so we're going to pop these into this expansion and see what happens. So we've got 1, and then, which is the same expansion here, plus of this one, so it's minus x cubed over 3 factorial. Now if I put in the next one, so if I put minus x cubed over 3 factorial into this, this will turn up to be x to the power of 6, so I don't need to write any more terms. Okay, so just need to tidy up this expansion. Only need to write up to power of 4. So I'm going to multiply it by 1, which is the same. I'll write factorials as well. This one is going to go to 1 times 2 times 3. Sorry, 1 times 2 times 3. That's right, yes, 6. And then times 4 is going to be 24. And then we're going to multiply it by this. So how many do you need to multiply? You need to multiply 1 by that. So it's minus x cubed over 6. And then times it by x, so I've got minus x to the power of 4 over 6, and that's it, because the next one you will be multiplying it by s squared. So any collecting, oh okay, so this one nicely cancels, so you've got 1 plus x squared over 2, and then over here you've got x to the power 4. If you times that by 4, that gives you minus 3 over 24, which is minus 1 over 8. Oh yes, we cancelled that. There you go. We have not been asked to comment on validity of this expansion, so that leads to exercise 2D and the mixed exercise as well. So I'm going to do a video with some helpful hints on the exercises in this chapter. So if you get stuck, watch the videos, and hopefully then you won't have any problems. If you do though, ask for help.